Hello, I'm very happy to speak to you whenever and wherever ever you happen to come upon this video. I would like to thank the Flemish Book Historical Society for inviting me to give this talk, and I would also like to thank Dr. Soetert, whose name I hope I haven't butchered too badly, and all those people who always work in the background on lecture series like this for their very kind collaboration in the preparation of this talk. Also, scanned books are a huge factor in the everyday work of bibliographers, with about 85% of incunabula editions being available in at least one scanned copy, and at least for Germany, something in the area of two-thirds of editions from the 16th and 17th century, namely the material recorded in VD16 and VD17, being scanned. Working with scans is by no means unusual or new. I'm not trying to pretend that in any way. It does, however, have a few implications, and I'm not quite sure we've thought through them completely yet. In this talk, I will describe issues this brings with it for us as bibliographers. I will propose some new approaches to deal with these issues, namely new metrics, and give my opinion on the implications of these probably necessary new approaches may have. Before I start proper, I would like to emphasize that nothing I talk about now is intended to be understood as a plea to no longer work on the actual book in an actual library. This is the gold standard, and it will remain that for the time to come. Working on the original has many advantages work on digital representations can't hope to replace. But often enough, we cannot work on the original due to a lack of time, or a lack of money, or a lack of both. Alternately, because we lack the ability to be at two places at once. Yet we wish to compare two books that are not in the same library, or to compare many books in many libraries. Here, scans are immensely valuable, yet they do not allow us a few things bibliographers are used to do. One of them, and the one I will focus on today, is the seemingly trivial act of using a tape measure or a ruler to measure the size of a wood block, the line of height over 20 lines, as we do for type identification using the Proctor-Häbler method. You can, of course, measure in digital images with ImageJ or Photoshop or whatever your program of choice is, but that, unfortunately, is not very precise. In order to have any frame of reference, you need something of known length in the image and in the same plane as the page you want to measure. And this very often doesn't work very well. Here you see a fairly representative example from Herzog August Bibliothek in Wolfenbüttel, and this example is not chosen to be unkind to the lovely and competent colleagues at HAB. I could have taken examples from most libraries with the same or a very, very comparable result. In this example, there is a scale, great, but it is next to the book, not on the book. This means that it will be somewhat distorted due to the parallax error that is introduced by two objects not being in the same geometrical plane. The error will not be huge, but if you want to compare small phenomena, it will be large enough to cause issues. But even if we have a scale on the page, measuring in software doesn't work very well. And you don't have to believe that, because I say you probably have experienced it yourself, and if you don't believe it, just try it out. Take a measurement, by hand and take a photo of the page and try to measure the same thing at home on your PC. You will not get the same result. Even if we have a scale on the page, measuring in software doesn't work very well because the book we work with, the old-ish book, tends to be warped or wrinkled or bowed. With a tape measure, I can either conform to this, so the tape measure also makes the same bow or wrinkle, or I can ever so carefully massage the book into a shape that is better suited to being measured. Please, librarians of this world, note that I said carefully. I don't mean that we put extreme pressures on something, but even if I just lay a ruler gently on the page, this makes the page conform a bit to the ruler, and this is something we take advantage of very frequently. Images, of course, can be virtually flattened. You can do that. Some scanning software even does that automatically. But they cannot do that in a way that allows for precise measurements because basically they stretch out the page a little bit in order to achieve the optical illusion of a flat page, which can be very helpful for many things, amongst them OCR. But it's not useful if I want to measure a distance. There are no doubt methods and technologies that allow for highly precise measuring in images, such as laser-based methods that are often used in quality control for PCBs and other industrial contexts. The technology obviously exists. However, unless we rescan everything, this won't benefit us, and I don't quite see us finding the motivation, the funding, or in any way a reason to do so. And we need to measure, to compare and to identify editions, copies, fonts, woodblocks, and many other phenomena. So not being able to measure won't do. So what can we do? One approach is to use a measuring loop. As optical tools go, this is actually a fairly cheap option. I think this one was 70 or 80 euros. I mean, that's cheap is a relative word, of course, but compared to what cameras can cost, that is relatively cheap. This is a magnifying glass that is firmly attached to a transparent scale that sits on top of the page you want to analyze. If you take images through this loop, you get very precise measurements indeed. The resolution of these scales goes up to 1/10 of a millimeter. Way more precise than anything we ever measured with a tape measure. At least mine don't go anywhere near that. This is an approach that my colleague Ricardo Oloco from Bolzano pioneers, and it works brilliantly for his in-depth studies into the Venetian type production. Unfortunately, this approach also means that I have to go to the original book and take a new photograph, or actually not one, but many, by hand in order to get my measurement. Brilliant as the results are, this does not solve the problem of measuring in scanned books. And to be fair to Ricardo, he doesn't pretend that it does. It is a very specialized method for a very specialized purpose. Again, we will not redo anything like this for millions of pages of printed material. We will have to find a way that works with what we have. I'm now trying to suggest two somewhat connected approaches that I've been working on with a team including Saskia Limbach at Johannes-Gutenberg Universität, now University of Göttingen, Vincent Christlein, Matthias Suret, and Angelos Nikolaou from the Pattern Recognition Lab at FAU Erlangen-Nürnberg. All scholarship is teamwork, and DH is even more so. I couldn't have possibly done anything I present here today without them. On to my first approach. Well, if we can't measure in scans, let's avoid measuring. One conclusion from the described problem might be to simply not measure at all, but to compare shapes. Maybe it is a better idea to not measure line height over 20 lines, but just compare the letter shapes very minutely. Looking up examples would have been very difficult and tedious manually, but computers are great at tedious jobs, so we can use them to look for similar bits of image and create glyph tables that don't look like this, the GFT table you all know and, well, love or hate, depending on what area you're working on and how reliable they were for you, but much more like this. The glyph tables we can extract can even be significantly better than the manually compiled ones from the turn of the last century that tend to be a bit idealized. The main advantage from doing this is that we do not only have one glyph of slightly questionable representativity, but lots that make comparisons significantly, well, maybe not easier, because we've got more material to compare, so the task is actually more challenging, but more reliable. One entity of comparison, for example, might be a snippet showing a single character. I cannot very well tell you how tall and how wide these characters are, but using a tool called Glyph Collector, developed by Gabor Kerekes from The Hague, I could find all the other, or close to all the other instances of this character in a given book, as long as it's scanned. And I could find them in other books too, and compare them. Pattern recognition, the discipline that is working on problems like these, has made fantastic advances in recent years. If you use Google image search to find out what species of plant you are encountering on a hike, pattern recognition. If you speak to your phone, pattern recognition. If your car can tell you what speed limit there is because it read the sign at the side of the road, pattern recognition. There are several ways of achieving this functionality, but what has proven to be very powerful in recent years is the use of neural networks. I'm a book historian and not a computer scientist, and I'm not going to try to give an introduction into this topic. There are many out there. I can only invite you to have a look at them. But from a functional point of view, we don't even necessarily need to understand how they exactly work. Basically, a black box idea will be sufficient, at least for the argument I'm trying to make here. Neural networks need to be trained with known true information. So if you want a pattern recognition or a neural network algorithm to recognize a specific phenomenon, you need to show it many instances where you have, for example, an image and a given bit of information. An image of a given type and the information what type is visible on this image, and so on. The more information you can provide to train, the better the results are, generally speaking. For a first project we finished last year, we labeled around 35,000 images of pages with the main text font like Textura Rotunda, etc. visible on the page. This was a fairly rough classification, of course, that still proved very useful for OCR, but it also allowed us to see how good this approach can work for analyzing typography. And it worked fairly well. Overall, we achieved an accuracy of over 99%. If you want to try it out, the OCRD font group classifier, as it's called, is available online for everyone to use. It does not have a graphical user interface, I'm afraid, but it is very simple and very fast. And if you want to try it out and have an issue with it, just contact us. We're very happy to see this actually in use. Currently, we are preparing, please read that as wait for funding, to identify individual incunabula types using very much the same approach. This is significantly more challenging since we have much less material to train with and not 9 font groups, but several thousand types. However, if we don't hit our target perfectly, but succeed in suggesting, say, the 10 or worst case, maybe even 20 most probable types, and leave the user to compare glyph tables for those, it will still work, and it might very well still be quicker than measuring over 20 lines and search for the correct M shape and so on. We can also leverage those many cutout snippets I showed you previously that we generate for glyph tables. They can be used to be pasted together to form new simulated pages, kidnapper letter style, that seem to be printed in any given type. They won't fool you and they won't fool me. Frankly, they won't really fool any human, but they don't need to. They only need to show the graphical peculiarities of a given type in many different variations so that the machine can learn what this type looks like. My colleague Matthias Suret has developed a way to smooth these snippets together quite convincingly, I feel. Please ignore the type itself. He did this demo with everything he found lying around, literally or figuratively speaking, on the room of the cutting room floor, on the floor of the cutting room. I'm sorry. It is only meant to show how those different snippets can be blended together. The charm of this approach is that we can make lots of training data, millions of pages if necessary, and if we find enough computing power, for our neural networks, even if we have fairly little surviving material, a problem, as you well know, we will encounter for many, particularly incunabula types. So to end this deviation from measuring into pattern recognition, replacing measuring with something else is not trivial, but it's increasingly becoming an option, and I do not think that anyone will be sad if we find a way that means that we don't actually have to measure over 20 lines and find the right-shaped capital M in order to identify type, but just look for the most probable candidates and compare shapes. So this function of taking a measurement to have a bit of information that can be taken from one book and brought to another and tested against some hypothesis there, this function might be replaceable by comparing images in some cases. However, it will not work for everything. The option of comparing lots of instances allows us to zoom in more than we usually did while working manually. We can look at kerning simply by widening our scope ever so slightly and not look at one individual character, but at character pairs. Again, we cut out one sample, run it through Glyph Collector, and hey presto, lots of, in this case, ATs. You can see quite a few here on this slide. Actually, we extracted something like 2,000 of them from one volume. If we are a bit unsure if two copies are printed from the same type, comparing the character spacing might help quite a lot. And taking that many examples into view makes results certainly a lot more reliable. But it also causes a problem because 2,000 cutouts are not something we can easily compare manually. It is also something where finding a similar one using pattern recognition doesn't really come into play. So we will have to find a way to quantify the distance between those two characters, i.e. to measure them. This is additionally made more difficult by the fact that these snippets, as you can probably see for yourself, are very similar, but nothing like identical. There is over-inking, there is under-inking, some of the type is a little bit damaged. There are various reasons why those impressions are not identical. And we would not expect them to be identical, but still we want to be able to compare them. And here we come to my second approach. Measure, but not in proportion. Measure, but in proportion, not in absolute units. We may not have absolute scale, not know the size of the type or the distance between two characters in millimeters. But we can measure width related to height, or width or distance compared to other distances within the same frame of reference, within the same scanning setup. One problem with this is noise. Since some characters are printed with more ink than others, some distorted because they are very close to the binding, others not perfectly printed for some other reason, we will not get consistent results, whatever we measure. But we have lots of data, remember. 2000 ATs give us some leg room to clean this up. This means that we can calculate lots of values and only take non-extreme ones. Say, throw the top and bottom 10% out. To give an admittedly arbitrary example, this might allow us to compensate for errors in extraction. We might occasionally, by accident, have extracted an OT instead of an AT, and this may lead to different values. As long as the remaining values are still representative of what we actually want to analyze, this may be a perfectly valid approach. Another approach we consider is to use skeletons. That is to calculate lines that run through exactly the middle, the spine if you will, for every character. These lines are defined as being equidistant to both outlines of the character. The idea is that even with more or less ink, the middle should roughly stay in the middle. This assumption will not be completely correct because occasionally, of course, more ink will have squished out to one side than the other, but if it helps to reduce noise overall, that is already a win. Here you see a first experimental implementation my colleague Vincent Christlein did. This also shows a few problems. Interrupted skeletons are of course no good at all. They are actually worse than the outline we started with. If these cases are rare, we may be able to work around them, put them just in the 10% of cases we ignore. If they aren't, it may be that skeletons are not the way. There are many other ways these repetitive micromeasurements could be taken. The number of pixels in the white space between the two characters, the shortest distance between them, the size of the area that the two characters enclose, and so on. The list could get quite long, and while I would love to present you a neat solution here, I can't. We aren't that far yet. I'm extremely grateful that the British AHRC and the German DFG have just a few weeks back granted us funding for a larger research project on the Werk der Bücher, where the team I already mentioned will work with Stephen Mossman and Ed Potton from the University of Manchester. We will look at, amongst other things, the Catholicon and the DK type, prime examples of research problems where minute differences in spacing and letter shape have been discussed extensively, and where somewhat similar methods have already been employed for a few years back by Paul Needham and Blaise Aguirre-Yarcas. And in this project we will try out all these variants of measuring type this way, and try to get to a metric that can hopefully convince you all is useful. The challenge for this is that such a metric needs to be more or less universal in application, as precise as possible, and easily cross-examined. And this is a fairly tough circle to square. I do, however, believe that the solution will lie in making the metric as simple as it possibly can be. M shapes plus size was so successful, and still is, because it is simple. It is actually somewhat arbitrary. We might have used the capital R instead of M, but it is simple in application, so it worked. Our solution will have to be simple too. Hence, we will first try the simplest approaches. Probably the simplest one is to identify some frequently occurring character pairs and measure one of the more primitive metrics for distance between the two characters, probably the shortest line across the gap or something like this. If we can get it to work like this, we will propose something along those lines as the new metric. If there are issues, we may have to introduce more complex solutions like the skeletons or other more advanced tools. But I do believe that you should be able to cross-examine a result basically with MS Paint, and patience in the case of MS Paint, if you really have to. I wouldn't want to propagate MS Paint, obviously, as a research tool, but I think we have to keep it simple enough that it might be possible. If our metric is a black box that has to be believed, since it is too complex to be checked, if this happens, we lost. I am, however, convinced that this needn't happen, and that proportional measuring is the way forward for measuring in bibliography, not least because we can now measure things that we couldn't before, and can take many, many more data points than we manually could have done. And because this might allow us to go both very in-depth and very large scale. We can measure between individual characters, which is way further zoomed in than i.e. Proctor Hebler ever was. It is also allowing us to compare our results across vast amounts of data for other printed material, even books from printers we hadn't even suspected to be vaguely relevant material, simply because we can outsource the tedious bit to the machine. As enthusiastic as I am about this, it will not solve all our problems, obviously, but it might actually help solve a few, and I'm sure it will help us find lots of interesting new ones. If you have any remarks or questions, I would love to discuss this topic with you. Firstly, live on 1st of December, 8 to 9 p.m. Central European Time. But if you're not available then, or if you see this talk at some point after this, you can always send me an email under weichsel@uni-mainz.de.